Next, let's see configurational isomers. Configurational isomers can be interconverted only by breaking and reforming a bond. So here in conformational isomers, you don't have bond breaking or bond formation. But in configurational isomerism, they can only be interconverted if a bond is broken and then formed again. There's two types of isomers. There's Cis Trans and Isomers, and then optical isomerism. Let's see the Cis Trans-Isomers. So whenever there is a double bond between two carbons, rotation is not possible around a double bond. So a single bond allows rotation, but a double bond does not allow rotation. So Cis Trans-Isomers only occurs in alkenes. You need to have a double bond. And Cis Trans-Isomers occurs whenever there are two different groups attached to each carbon. So this carbon has one group, one substituent, and another substituent. So here you have two different substituents, either substituent R1, which is H, or substituent R2, which is CH3. So here, if you break the bond and you rearrange it, you can have another version of the same molecule. So same molecular formula, but different arrangement in space. So you have these two CH3s are on the same side. These two CH3 are on opposite side, and they can only be converted to each other if the carbon double bond is broken and reformed. Because you have that pi bond here, it does not allow for rotation. If it would be just a sigma bond, rotation is possible, but because you have a sigma and a pi bond, rotation is restricted. So if you have a molecule where you have two different substituents, let's say substituent X and Y, so if these are exchanged, the positions are exchanged, you can end up with two isomers. So when they are on the same side here, it's called the Cis Isomer. When they are on opposite sides, sorry, this is Y and this is X. So when they are on opposite sides here, this is called trans-isomer. And we can extend this reasoning in cycloalkanes as well. And here the rotation is restricted because you have that ring system. So because these two are on the same side, so it's a cis isomer. Here they are on opposite sides, it's a trans isomer. Here the Cl on the same side, so cis. Here the Cl on the opposite side, trans. Here as well you have a ring system. So same side, cis, opposite side, trans isomer. Again, another example, same side, cis, opposite side, trans. Here. Now let's see Ez isomers. Now cis and trans isomerism is restricted when you have two different substituents, R1 and R2. However, if you have different substituents, let's say you have R1, R2, R3, R4, and they are different from each other, then we have to use Ez isomerism.